Imagine this. You're scrolling through a forum late at night trying to install a piece of software on your Linux system. Maybe it's a newer graphics driver, maybe it's a media tool, maybe it's some flashy customization package that promises better performance, cleaner visuals, or one-click convenience. Someone in the comments says, just add this PPA or enable this COPR repository, it works perfectly. It looks simple, one command. Maybe two, you copy and paste it without thinking much about it. The software installs, your terminal finishes the process, and everything seems fine. But what most Linux users never realize is that in that exact moment, they may have just handed over deep system-level trust to a complete stranger on the internet. That's the part nobody talks about enough. Linux users love talking about freedom, customization, open source power, and control. But with that freedom comes responsibility, and one of the biggest hidden dangers in the Linux world is blindly trusting random PPAs and COPRs. These repositories can completely change your system, replace core packages, introduce unstable dependencies, create security vulnerabilities, break updates, and in worst-case scenarios, become a direct path for malware or system compromise. And the scary part is that most users never notice the damage until it's too late. Today we're going deep into why you should never use random PPAs or COPRs carelessly, how these repositories actually work behind the scenes, why they're more dangerous than most people realize, and how tools like WinBoat can help you stay safer, more stable, and more in control of your Linux environment. First, let's understand what a PPA actually is. PPA stands for Personal Package Archive. It's mainly associated with Ubuntu and Ubuntu-based distributions. A PPA allows developers or individuals to distribute software packages outside the official repositories. On Fedora-based systems, the equivalent concept is often COPR repositories. They exist because official repositories can sometimes move slowly. Developers want faster updates. Users want newer versions. Hobbyists want experimental builds. So PPAs and COPRs became an easy way to distribute software. And to be fair, not all PPAs or COPRs are malicious. Some are maintained by trusted developers with excellent reputations. Some solve real problems. Some provide software that genuinely improves the Linux experience. But the issue is not whether all PPAs are bad. The issue is that users have normalized trusting repositories without understanding the level of access they're granting. When you add a repository to your Linux system, you are not just downloading one app. You are telling your package manager that this source is allowed to provide software updates, dependencies, libraries, and potentially replacement packages for your machine. That's massive trust. This isn't like downloading a random zip file on Windows. Repository integration goes deeper. Much deeper. Think about it this way. Your package manager is one of the most trusted components in your operating system. It handles software installation at the system level. It interacts with root permissions constantly. It manages libraries used by other applications. And when you add a third-party repository, you're effectively expanding the circle of trust that your operating system relies on. Now imagine giving that level of trust to a random GitHub page with 5 stars and no reputation. Most people never stop to think about this because Linux users are conditioned to copy and paste terminal commands from forums, Reddit posts, YouTube tutorials, and blogs. The culture itself unintentionally encouraged risky behavior. Someone says, paste these commands. You paste them. If it works, great. If not, reinstall the system later. But what happens when that repository becomes abandoned? This is one of the most common dangers. A repository may be maintained actively today, but abandoned 6 months later. The developer loses interest. The domain expires. The signing key stops being updated. The packages become outdated. But your system still trusts that repository. Your package manager still checks it during updates. Your machine still depends on packages from it. Now your stable Linux installation slowly turns into a dependency nightmare. One day, a system update conflicts with the outdated packages from that abandoned PPA. Suddenly packages can't upgrade. Important libraries break. Your desktop environment crashes. Your graphics stack becomes unstable. Boot issues start appearing. And now you're spending hours debugging a problem that originated from one random command you copied months ago. Linux veterans have seen this happen endlessly. There are users who break their systems trying to get the latest Mesa drivers. Others destroy dependency chains by adding experimental KDE repositories. Some install random kernels from unofficial sources. Others pull Python libraries from obscure PPAs that conflict with official packages. At first, everything feels faster and newer. Then the system slowly becomes impossible to maintain. This is why experienced administrators often follow one golden rule: the fewer third-party repositories, the better. The danger becomes even worse when security enters the picture. Let's talk about supply chain attacks. A supply chain attack happens when attackers compromise a trusted distribution method instead of attacking users directly. Instead of hacking your computer individually, they compromise the software source itself. And repositories are perfect targets for this kind of attack. If a malicious actor gains access to a poorly secured PPA or COPR account, they can potentially push compromised packages to every user who trusts that repository. Imagine a modified package containing spyware, cryptocurrency miners, credential stealers, remote access backdoors, or data exfiltration tools. And remember, package managers often operate with elevated privileges. This means malicious installation scripts can potentially execute with enormous system access. Now, some people immediately say, but Linux is secure. Yes, Linux can be very secure. But security depends heavily on user behavior. Linux does not magically protect users from poor trust decisions. In fact, Linux often assumes the user knows what they're doing. That assumption becomes dangerous when inexperienced users blindly trust internet commands. Another huge misconception is that open source automatically means safe. This is one of the biggest myths in tech. Open source means code can be inspected. It does not mean the code has been inspected. Most users never audit source code. Most users never inspect package contents. Most users never review installation scripts. They simply trust that somebody else has done the verification. Attackers know this. That's why malicious packages can remain unnoticed for surprisingly long periods. A package might look legitimate while secretly including harmful post-install scripts, telemetry components, or hidden persistence mechanisms. And sometimes the danger isn't even intentional malware. Sometimes it's incompetence. A poorly packaged repository can accidentally overwrite critical system libraries. It can package incompatible dependencies. It can disable important security protections. It can create unstable configurations that expose the system to vulnerabilities. The result may not be immediate compromise, but it still damages system integrity. One of the worst habits in the Linux community is the obsession with always having the absolute newest version of everything. People constantly chase bleeding-edge packages without understanding the trade-offs. Newer is not always better. Official repositories exist for a reason. Distribution maintainers spend enormous amounts of time testing package compatibility, dependency relationships, stability, and security updates. They curate software carefully to ensure the operating system functions reliably. The moment you bypass that ecosystem with random repositories, you're stepping outside the safety rails. Now, sometimes that's necessary. There are legitimate cases where official repositories lack needed software. But random experimentation should never become your default approach. This is where a tool like WinBoat becomes incredibly important. WinBoat focuses on controlled, safer environments rather than blindly modifying your core Linux installation with random package sources. Instead of polluting your main operating system with unknown repositories, tools like WinBoat encourage isolation, separation, and more manageable software environments. That matters because isolation is one of the strongest principles in modern security. If experimental software exists in a contained environment, the risk to your main operating system becomes dramatically lower. Think about how professionals handle risky environments. Developers use containers. Security researchers use virtual machines. Enterprises use sandboxing. The reason is simple: isolation limits damage. But average Linux users often do the exact opposite. They install experimental repositories directly into the core operating system they rely on daily. That's like modifying your car's engine with random internet parts every weekend, and then acting surprised when the vehicle stops working. Another major issue with PPAs and COPRs is key management. When you add repositories, you often import signing keys. These keys tell your package manager which repositories are trusted. But many users import keys without verifying fingerprints, sources, or authenticity. This creates another attack surface. If users are tricked into importing malicious signing keys, they may unknowingly authorize dangerous packages. Some outdated tutorials even encourage unsafe practices like using deprecated key management commands without explaining the risks. And the internet is filled with outdated Linux tutorials. That's another hidden danger people ignore. A blog post from 5 years ago may still rank highly on search engines, even though its instructions are obsolete or unsafe. New users copy commands without realizing the ecosystem has changed. Repository formats evolve. Security practices evolve. Package management behavior evolves. But outdated content remains online forever. This creates a perfect environment for accidental system damage. Now let's talk about dependency poisoning. This is where things become especially ugly. Linux systems rely heavily on shared libraries. Many applications